And let's take a look at what we have. If I hit the 5 key, and I select this control, let's keep an eye on the blend shape. Yeah, and it's triggering properly until it gets to the 0 state. Let me see what happens if we go past. Nothing happens. But what's important is that I get to a 1 sooner than that extreme pose. So I start to get my fix really early around here. And beyond that point, I just get an overdrive. So I think with this approach, I don't even need to go into the curve editor to do any of that infinity stuff, right? So this is a very good approach to take. And at any point in time, if you don't like how it's triggering or when it's triggering, you can come and adjust these adjusters, right? Move them either farther away. Like if I was to take it right now, it's at 46 right now. If I move it farther away, it's impacting the blend shape. If I move it closer, it's impacting. So it's a way you can come in here and fine tune your results, but I'm going to leave it at 46. So this is the shrug. It's sorted out. Okay, so now let's resolve the protraction and the retraction. Let me set this to 0. And I'm going to load in the distance node for protraction. Hit the down key to access its shape node, load driver, grab distance, grab protraction, left side, and set a key. Then I'm going to rotate this forward to about there, which is way more rotation than I could ever need. And that's on purpose because I'm going to overdrive this value to this one. I'll go a little higher to like a 1.3. I think that's what I worked with previously. Anyway, we'll see. So I'll go key. All right, so let's test this out. If I grab this thing and okay, so it's triggered at around the time I want it. And when we return to our default, we're back at 0. So it's good, it's working nicely. I do want to see how the retraction operates. Yeah, this is good. So it triggers really early before we get to that extreme value that we will never get to. Yeah, this is a much better approach using these locators. It makes the setup is a little complex, but ultimately it makes for a more intuitive end result when it comes to editing it. All right, let me do the retraction. I'm going to hit down for this last dimension, load it as the driver, grab the distance, grab the left side. Let me make sure this control is at 0. Yes. Set a key, grab this control, rotate it. So we're about there. Way extreme. All right, and I'll set my retraction to 1.3. Okay, so that's super extreme, and I now set a key. And let me test this out. So I grab it, and yeah, that's very nice. Yeah, very nice. A nice squeeze over there causes the pinching, and it interpolates nicely. And for this, I'm going to leave the easing in and easing out. Every time I have to do a linear, I'm a little wary because linear interpolation doesn't feel too organic. So the fact that I'm able to use this approach where I get a nice easing in and easing out of the curve will make for some better results in the viewport, or more animation friendly results. So this is what I'm talking about. If I go to if you're not too familiar with what I'm going on about, I'm talking about the fact that it's great to have these curves, yeah, like this, ease in and ease out, right? It's a good thing to have. It's just that when I want to do that cycle infinity thing, I do have to go with linear. All right, so this is my end result. It looks like it's working nicely. Everything is triggering correctly. And so is that. Yeah, that feels good. I like how the tissue is moving up and everything. Now, I usually do like to do both sides in the video, but I'm not going to do that. I'm not going to waste your time. You saw me do this, and I'm going to go off screen and do the right side, and I'll come back when it's done. But I'm doing that because I am going to be utilizing this approach to fix some of the PSDs I've already done, and let me show you why. So if I zero this out and we take a look at the PSDs I already did for the shoulder. So if I grab my shoulder control, right, as expected, if I do an abduction, it triggers the correct morph. And if I do an adduction, it triggers the correct adduction morph. But look what happens when I rotate in another axis. I'm rotating forward, and it's triggering the abduction. This is not good, right? This is what happens when you try to rely on rotation parameters for triggers. And also going the other way, you see it's triggering it. This is too much triggering going on for the wrong direction. And if you look at the actual joint we're counting on, you'll see why. If I go into the offset parent matrix section, right, I'm going to pin this window so it doesn't disappear. Study what's happening at the rotation. So if I go like this, it's changing several parameters. So this is that gimbal-like behavior. Now I do want to use this opportunity to return back to my solution tree and show you something that I had put in there because I did have it in the back of my mind as an alternative solution for dealing with triggers. And it's this little addition about angle rotations. But I just put it there because I wanted to remind myself that that was an option that I had once seen in one of the advanced skeleton tutorials. But I don't think angle rotations are accessible to the new custom control system. When I first saw it, I remember seeing it under the pose tab, like under the driving systems. And it was under this corrective shapes option. And right up here, there was an option for checking angle rotations. And it was a way that advanced skeleton, I suppose, was converting rotation values for limb rotations to a float value that you could use to trigger corrective shapes when you're rotating in specific axes. And it bypassed the whole gimbal lock issue. So even if you were rotating, you were seeing a whole bunch of values jumping here, you'd notice that you'd have some angle rotations that were just moving in their respective axes that you were rotating in. But I do remember that there were some limitations with those angle rotations, something about only being able to use it if you're using a maximum rotation of 90 degrees or something. But it doesn't matter. It looks like it was deprecated. And it was deprecated and it's been replaced with, I suppose, this Q rotations, which makes more sense. I think Q rotation stands for Quaternion Rotations, and they are better to rely on than Euler rotations, which is what I'm counting on when I use that decomposed matrix. I'm counting on Euler rotations. But if you do any research, you'll see that Quaternion rotations are much better to rely on for blend shape triggers. As far as Quaternion rotations are concerned, I don't think it would do a much better job. And let me completely rule that out. So if I go into the node editor and I open my bookmark, so if I was to open my bookmark here and I was to look at this decomposed matrix for the left shoulder, if I select it and then I unpin this and pin that, you see this output quaternion. It does at least try to give you the option of having quaternion parameters. Let's see what happens with this pinned when I'm rotating to see if there's that much of a change in the other axes, because this rotation here would be a, let me see this would be a Z rotation. So as I'm rotating in the Z, yeah, there's still changes here. I don't think they're that significant. Yeah, here they're not too significant. But changes are happening nonetheless in all these three parameters. And when you're just rotating in one axis, so if I was rotating in the Z here, I will still see some movement here. Quite frankly, I don't think it's going to do that much of a better job, but you can try that. You can try using this quaternion parameter as your driver. If you load it in here as a driver, you have access to them, so you can try them out and see if you get less of a triggering of your blend shape when you're going in the other direction. Because if it's less, then I suppose it's not a bad option to go with. So I am going to redo this shoulder triggering with this approach, and that way you'll get to see me do the approach one more time in a different section, but I'll pretty much be using the same principles that I used up here. It's a very important system of parenting and constraining, and we need to get it down. But I do want to show you something though. If I was to go down here to the foot, that one I think I might leave alone, because rotation in other axes do not aggressively trigger the foot. So let me show you what I'm talking about. Like here, not that I would ever do what I'm about to do. This pose is a broken pose, but if I'm going in this direction, you see on the outskirts, I have no issue. So I have no multi-axis rotation, and that's expected because this is the first rotation movement I'm making. So I'm not going to run into any gimbal issues this early. But if I go in the other direction, you see it's slightly triggering the ankle fix. But in this case, look at how minimal of a change is happening. It's irrelevant. It doesn't matter that it's triggered at 0.041. So here I'm going to keep the decomposed matrix approach. Like, it's not going to hurt this solution. It's going to be just fine. It triggers when it matters. When I rotate backwards, it does the correct thing and it fixes my issue. So definitely don't abandon this decomposed matrix approach. It's a simple solution that might work for some parts of your rig if you have a very simple morphix, and always check in the other axes to make sure it's not aggressively triggering your blend shape. But let's move on to setting this up. When I come back to set this up with locators, I'll have the right side of the shrug done.